And the last session of the day peaks probably furthest to the future. This is a session titled Novel Fiber Products. We have 3 presentations that cover quite wide area. This will be chaired by Mr. Ali Harlin, and when Ali Harlin gives a presentation, then we know that it will cover a wide area and really peaks far to the future. But I think that it's good to have such kind of views in the end of the day. About Ali, it would be easy to give a half an hour presentation telling only about Ali, but I like to summarize something. Research Professor Ali Harlin has a long track record on research related to material development. Currently, Ali is responsible for one of the biggest research programs at VTT called the Industrial Biomaterials. That program focuses on packaging, construction materials and consumer products. Ali has also different kinds of responsibilities related to steering the research on national level and in, for example, in forest clusters research programs. Ali usually plays some kind of a role there. Ali works as adjunct professor at Tampere University of Technology, not Tampere University of Tampere. That would not sound that wise. So, Ali, please.
Okay, thank you for everybody coming to this part of session, and so I want to congratulate also our watchers in Victoria in Australia. There is quite a late evening this time, and in the other way in the British Columbia, where it's quite a good time for take a coffee. So what I would say, this is a good practice for the hockey World Championship, which is starting in 2 weeks. So this is about the broadcasting time for that session. So believe or not, it's possible to make something else out of the wood than only paper and board, and that is about the whole story now. So where the thinking starts is that when we have a tree in a forest, it's growing there, but it's never only a stand. It has all its parts. What basically means that when we have purchased the raw material, we have basically purchased all the parts of the tree, and it's only reasonable to utilize it fully. And as we have understood already from the previous presentation of Jari Sirvi and so forth, it's very, very valuable that we look at that we really benefit all the raw material. And if we consider the future, it's as well coming to the fact that we don't have raw materials unendingly, and we have to kind of utilize it as thoroughly we can. So, but there is one particular problem, is that the easiest part has been applied first. So timber has been there, and the marvelous wood as a construction material has been applied as the first one. So wood age was before the stone age, most probably. And so we are coming in an age that we are in the pulping wood is kind of utilized raw material. And now we are kind of sliding to the next era of a time where we have to find even more efficient ways to utilize our raw material and be able to pay off all the residues as well and get the money back out of that as well. So in a pulping, I will show you soon the reason why we are pulping the tree and why that is the most attractive part of it. But the question is that about 50% of the wood we are purchasing in is not produced for the actual product, what is our primary product. So it means that we have a lot of side streams. And it seems that in the past 2 decades, forest industry has forgotten quite soon there is a things like chemical industry related to forest industry. So it was not very many times in the past when more or less all the pulp mills had some kind of chemical industry involved there. There were factories related to lignin production. There were factories related to the protein production out of it, tall oil, you name it. But it's not only for the past, it's also for the future. What has happened during these few decades is that we have kind of created an industrial monoculture, which is that the kraft pulp mills are much more in the scenery, and that means we have to learn something there. Why to do this is that if we compare the side streams, there is always utilized the energy value of the side stream. But if we take just the biofuel oriented biorefinery, so it means that the maximum conversion efficiency is something like 50% of total mass, and it's the maximum carbon conversion is something like less than 70%, and the maximum energy conversion is something like 90% or less. Okay, that is good. If we are chemically oriented, we can utilize nearly 90% of the whole mass, and our carbon conversion starts to be close to 95%. And what we learned already from the previous session, so this is absolutely vital. So, and there is many times proposed that gasification is a big thing, but its efficiency is not that high. So it's really that we have to make something added value materials out of the rest to make more money. And this is a little bit motivating it more, so that our annual growth of wood is increasing because the climate is very positive. That is particularly for the Nordic areas. As well, it means that because we have the, say, structural changes in our industry, that is as well causing a more volumes of trees which we can use still sustainably way. And so there is a very conservative way calculated, 35 million more cubic meters of wood coming on that market by 2030 in Finland only. If we calculate how much we have overdue of the forest, it's more than 50 million cubic meters. So it starts to be as much our fiber production is consuming at the moment. What we can get out there, we can go for gasification, we can get the Fischer Tropsch products, we can get the pero oils, so we can get the energy products. We can as well hydrolyze the recycled fiber, and we can get the sugars and produce alcohol, but we can produce as well added value components, not only a transportation fuel component. But it comes more and more interesting when we start to speak about extractives, because they can come to the high added value products. And particularly, and what I believe personally very much, is that out of the cellulose which we already can produce, we can produce even higher quality and even higher value products. So if we just make a simple thing that we take the volume of what can be produced out of the wood we are putting in the factory, and what is its price per ton, we see that very surprisingly the biggest turnover of a factory can be reached somewhere around 500 euros per ton, which is today's pulp price, and that is what the industry is doing today. It's just maximizing the turnover. It's not saying that it's maximizing the profit which can be gained out of it. If we are simply sliding in a direction that we are using more and more the energy components, what will come out is that we are not really benefiting all the possible incomes out of it. Yes, we are consuming the wood which has not been used for it and its size components. But where the thing really is that we have to find, to balance this situation, something with is more added value. And what we have to do if we want to do it, it's basically two things. So we have to find ways and processes and technologies how we can produce these more advanced things with less investment cost and with less operation cost. So it basically means that these new, more efficient technologies enables us to produce the new materials less expensive way, which as well means that we can sell them in a prices where the volume is increasing, and that is pulling through the whole industry to new level of net profit. Some very simple examples, but I will have good speakers to just soon telling more detailed on this. So fibers from wood industry. So we have a cellulose, we have a food fibers, we have a sawdust, we have all that. So we can take those components which are already readily available and we can modify them and we can make them compatible with the other matrices like plastics. And this enables us to kind of coming closer and closer to the plastic material, which is the dominant soft materials used today for production of goods. So we are living a plastic age, but my sincere belief is that by the 2050 we are living again in bio-based economy. And this is one of the first phases where it has really picked up is in the US, where it is used for deckings, for all kind of, say, construction. And why it's taken up there, it's a kind of waste management issue. But out of the waste management, we can really make added value products. So recycling is real in the materials here. But we can make something that is much more sophisticated. So these are only a few examples from the past years, like chairs, like car parts, like loudspeakers. There are many other examples coming. There was discussion about biopolymers and drop-ins. So I have been in a petrochemical industry, and this is very close to me, but the idea that the existing polymers, the existing synthetic plastics can be only made out of the oil is not really true. And there are now trends to go in a direction of bio-based. Only to get rid of the, say, dependence of the oil pricing, possibly, but not only. There are also other reasons. There are fractions of which can be used. But this example tells about polyethylene, most used polymer in the world. So if we can see several, there are dozens of ways to come to the polyethylene, but there is 4 examples. There is ethanol to olefins, which is the Braskem way. They are doing now it out of the sugarcane, but we can as well make the ethanol out of the waste paper, and we can make the, say, polyethylene out of the waste aamulehti or kauppalehti or whatever, if we wish. One way is a methanol to olefins. So we have a lot of sludge, we have a lot of sources, or we can gasificate and we can produce a methanol, and we can turn that to olefins, not only ethylene, also propylene. We have gasification and fissure drops, and there is a cracking, or there is a direct consumption of syngas as well, and that leads us as well to a possibility to produce a polyolefins. And we can as well take fatty acids like a tall oil, and we can crack it to the ethylene and go for polyethylene. All this is possible, and out of that we have the whole variety of all the 5 different types of the polyethylene and all the combined. So it's not only the biomaterial, there are also drop-ins. There is also a way of benefiting the existing structure of petrochemical and plastic industry with our products as well. The biotechnology has led us to the idea of cell factory. We have a long experience on cell factory. It was told about the lactic acid development and so forth. But that is not even just a slight beginning for it. There are now 2,000 of emerging biopolymers which are based on cell factories, and there is a science which is interfacially developing the genome of cells and developing a new kind of organism which can produce all kind of components. But that is only when we are so end of the raw material utilization that we have nothing less than the sugar. But we can make it as well quite efficiently and the materials if we utilize the polymers as they are created. So nature has made it for us. So cellulose is marvelous polymer. And even though the cellulose is used for some time, it's not really chemically worn out. But let's look at what we can do if we utilize a regenerated cellulose or for man-made fibers, or viscose if you wish, or rayon. But there are also new much more, say, environmentally friendly ways to do it. Like if we take the cotton production, it's about the Finland's land area, what it occupies, and all the water in the rivers of the world, what needed to hydrate it, and a lot of fertilizers and pesticides, etc. So if we only take a half of that overdue of Finnish wood, what we can do is that we can produce a cellulosic fibers, man-made cellulosic fibers, which is 20% of the world cotton production. 20% of the cotton production in the world, 1/5. Which basically could mean that we could prevent of desertation so much that we can feed at least 20 million people of food produced on that area. So it's a marvelous thing what we can do if we just want to go there. And on a bottom line, it's just 10 billion euros, but maybe even that is interesting. We speak about nanocellulose. There are several things what is going on. So North America is developing a nanocrystalline cellulose, which is, say, part of the composite, which is crystalline filler, very good for barrier properties. We are producing a new kind of, say, nanofibrillated cellulose or microfibrillated cellulose, which is long fibers, but not as fluffy. Amorphous, yes, but it gives a very good added value for the materials. And wherever it can be used. So it's going in direction of the application. So from natural removables to composites, from biocompatibility for new kind of construction material. So this is like a kaleidoscopic, so that it's hard to understand what all kind of applications we have, even though it's just in a cradle and it has give its first cry. But it will grow, you see. So as a summary, so forest industry, here we have two different approaches to go. One is that we use the side streams, like wasted carbons, and we put it in a bioenergy. And sometimes, and in the end of the materials life cycle, it's wise thing to do to take the first service out of that material. We need the energy. Every factory has to roll. We need the energy. But there is also a new way of applying the feedstock. So for new products, for higher added value products. And on my perspective, I just see a green Klondyke. And in this Klondyke, there is nothing like a waste even existing. And we don't have a afford in a future to have something like that. So we are cascading the values and picking up the residual values and recovering it. So to summarize it, so I see quite a bright future for the material-based success in the forest industry and 6 areas for it. So nanocellulose for performance, fiber materials for recycling, wood-based constructions for healthy buildings, new platform chemicals to consume less oil, engineering materials for renewable, from renewable sources, and not the least, the cellulose textiles for anti-desertation. So thank you for your interest. I've used all my time.